Hello Year 12 and welcome to our 8th and second last penultimate video for series and sequences. In our last video we did the sum of a GP, and this time we're going to look at the limiting sum of a geometric series. Now what I mean by this is I want to find the sum of all of the terms, if you like, the sum of an infinite number of terms. Now for most GPs that would be, or for many GPs, and for all APs that would be an infinite number. However, where the common ratio is a small number, where it is less than 1, multiplying by a small number makes each successive term smaller and smaller, gets closer and closer to 0. Now it happens that when I add all of these together, there's a limit to which the sum converges, right? It approaches a certain figure as I add more and more terms in that series on there. Now, we could use the GP formula and sort of consider what happens if n becomes very, very large. There is a proof in the textbook if you want to have a look through it, but I'm just going to jump into it here and say my formula, which is quite simple. The sum, or the limiting sum is how we describe this. If you like, the sum to infinite terms is a over 1 minus r. Simple as that. So, let's have a look at how this works. There's the formula. If you need a good close look at it, again, on your formula sheet. So, I want to calculate the limiting sum of this GP, 10, 9, 8.1, and so on. So, the first term is 10, a equals 10, and the common ratio is 9 over 10. Rightio. So that's what I need there. And the limiting sum is a over 1 minus r. So 10 over 1 minus 9/10 is 10 over 1/10 is 10 multiplied by 10 is 100. There we go. It's the limiting sum. That's all we need to know. Rightio. So if I have a GP where r is a small number, it'll have a limiting sum, right, which we write like this, a sum with the subscript infinity, and we calculate that as a over 1 minus r. Rightio. That's it for today. Our next and final video is recurring decimals and the geometric series. Rightio. That's all. If you've got any questions, make sure you ask in class. See you there.